In this lecture, you're going to learn about the other address classes, that's Class D and Class E. So you saw in the last lecture that classes A, B, and C include all the addresses that are valid to be assigned to our end hosts. And those addresses went up from a 1 in the first octet up to 223. But you're maybe thinking, what about 224.0.0.0 to 255.255.255.255? Because you know that the maximum value in each of our octets is 255. We only went up to 223. Well, the next class is Class D. And Class D is used for multicast addresses. You'll learn about what multicast is right on the next slide. With Class D, the 4 high order bits, the first 4 bits in the first octet, are always set to the binary value of 1110. We can actually count this up. If you look at the first octet down in the bottom left here, we've assigned the bits 1110. A Class D always begins like that. So if we add these up, 128 plus 64 plus 32 is 224. So the lowest address is going to be 224. And then the remaining bits over to the right are 8, 4, 2, and 1. If we add those up, it adds up to 15. And 224 plus 15 adds up to 239. So that's where we get the range of 224 to 239 from. These Class D addresses were not allocated to hosts, and there's no default subnet mask. They're used just for multicast traffic. So to see how multicast works, let's do a quick review of unicast first. I've got my sender over on the left, which has got the source IP address 10.10.10.10, and it's going to send traffic to destinations at 10.10.10.15 and 10.10.20.15. So it sends traffic to 10.10.10.15, and if you looked in the packet in the layer 3 IP header, you would see the source IP address is 10.10.10.10, the destination is 10.10.10.15. And if we're using a /24 subnet mask, they're both in the same subnet, so that traffic can go directly between the hosts without having to go via a router. Let's say that the host then sends traffic to the other host up in the top right. Let's say that this is a video stream that we're sending again. So we've unicast it to 10.10.10.15. We then unicast it to 10.10.20.15 as well. If you look in the IP header, again, unicast traffic, the source address is 10.10.10.10, the destination address is 10.10.20.15. Again, we were using that /24 subnet mask, so they're on different networks, so the traffic is going to have to go via a router. And if this was video streaming we were doing here, it's 2 completely separate pieces of traffic, so it's going to use 2 meg if it was 1 meg per stream. Now, we can improve this by using multicast traffic. With multicast traffic, we're going to send 1 copy of the traffic from 10.10.10.10, and that 1 copy is going to get sent to 10.10.10.15 and 10.10.20.15 as well. We're going to run an application on the sender, which is going to send it as multicast traffic, and in our example, we're going to send it to a destination multicast address of 239.0.0.1. It still comes from the same source address of 10.10.10.10, and the destinations still have their normal unicast addresses there as well, but we send it to this special multicast address. That will then go to all of the hosts that were interested in getting that traffic. Now, a good analogy of this is you can think of it like tuning into a radio station. So on most hosts, 10.10.10.15 and 10.10.20.15, they ran an application on there that said they wanted to receive the stream for 239.0.0.1. Now, as long as you've configured support for this on your routers, that traffic will get forwarded to all of the hosts that are interested in receiving it. And the benefit you get is, example here, we're only sending 1 meg's worth of bandwidth rather than 2 meg. And if there was 50 interested hosts, it would still just be 1 meg worth of bandwidth rather than 50 meg. So you save a lot on the bandwidth that you're using. It makes things a lot more efficient. Moving on to Class E addresses, they are experimental and reserved for future use. The first bits in a Class E are always set to 1111. So again, if we count it up, that's going to give us possible values of 240.0.0.0 to 255.255.255.255. Just like our Class D multicast addresses, these addresses do not have a default subnet mask. There is one special address that is actually used in Class E, which is the broadcast address of 255.255.255.255. That is the broadcast address for this network, meaning whatever network the source is on, it's a broadcast for that network. Actually, while we're talking about broadcast traffic, let's just go back to the previous slide for a minute, and I'll explain further about why multicast is different and can be more efficient than broadcast traffic. Notice in the example here, on the local subnet, the hosts that are attached to the switch, it only went to the top host at 10.10.10.15. The traffic did not get sent down to the host below that at the bottom. If this was broadcast traffic, it would be sent to all hosts on that subnet, not just the ones that wanted it. So multicast is more targeted, it's more efficient. Another difference is that as long as you've configured your routers to support it, routers will forward multicast traffic. So that's how we were able to get it to the host up in the top right. Broadcast traffic does not go outside its own local subnet. It does not get forwarded by routers by default. Okay, so that was our Class D and our Class E addresses. These Class E reserved addresses, they are never really used. You need to know what they are, and particularly for the CCNA exam, but real world, you'll never come across Class E addresses. They're not used in production environments. Class D addresses are used if you're using multicast. Okay, so that was our Class D and our Class E addresses. Let's just have a look at a summary of the different classes before we move on. So Class A is 12126 in the first octet. The default subnet mask is a /8. Class B is 128 to 191, and that defaults to a /16. Class C is 192 to 223, and that defaults to a /24. Classes A, B, and C are the classes that can be assigned to hosts. Class D is for multicast, that uses 224 to 239, and Class E is experimental, that's 240 to 255. You want to have these classes committed to memory, not just for the CCNA exam where they're completely essential, they're also completely essential for real-world networking as well. Okay, that's it. See you in the next lecture.